Mic check. Okay, hopefully I got mic. You'll see I have a slightly different setup. My old laptop is just not. Good morning, Linkridge. Good morning to everybody who's here. It's just a few of you, but good morning, Justin, Tim. Good morning. Hope everyone's doing well. So new setup. Um, anyway, I was streaming off my old Linux laptop, and the connector for my mic and headset is just too crackly anymore to be usable. So um, I switched to a camera with the mic on it. So hopefully everyone can hear this and the crackling's gone. There's a big truck outside my house at the neighbors, so hopefully you're not hearing too much of that. And the other thing about my new setup is that there's a chance you're going to hear my mechanical keyboard. So for all of us in the Linux class, I'm now sitting at a Windows machine running a virtual machine, probably like most of you are. So it is an upgrade in the streaming software, so that I guess is a plus. But I'm sad because my sort of battle-hardened Linux laptop is starting to give up the ghost. Okay, so normally as I will, I'll just sort of go to the Canvas page and call your attention to any updates that I've made, which for your class I have made a couple, and also let you know the status of my my progress in terms of creating future content for your class. So here we go. So I did put an announcement because I made some changes to the weeks of the. Apparently that's mid-erm. I'll go fix that after class. That's mid-term. Probably you could figure that out. Anyway, so I have made a couple of changes. I try never to make changes that make your life harder. I always would not make a change unless I think that you would come away with a slightly easier life because of it. So hopefully you find this to be true for the changes that I've made. So let me show you what those changes are. If we scroll down here to the schedule, so week 9, I was thinking that I was going to do a full week's worth of content in week 9, but it occurred to me that that is asking a lot of you to do all of the regular content for a week plus a 50-question midterm exam. So the midterm has 50 questions on it. So what I've done with week 9 is the only thing that you have on your plate that week is the midterm. So week 9 does not have normal content. I'll also show you the modules to show you what that looks like. So the only thing you have to worry about during the 9th week of class is the midterm exam. I will broadcast as normal that week, and I'll probably just sort of do some review for those of you who want to see a little bit of review before you go into the midterm. The midterm will unlock, you'll be accessible to you on Monday the 19th, and it will lock at midnight that Sunday. So you have the full week to do the midterm. I did the same thing for the week of the final. So I was going to do a full week's worth of content, but I dropped that. So the week of the final is only the final. That will be another 50-question exam, and that's the only thing on the week of the final. And just like I will do on the week of the midterm, on the week of the final, I will do a broadcast and I will do some review and answer questions. So 2 weeks worth of regular content are gone and replaced by you only worry about the midterm week, and you only worry about the final during final week. That triggered some changes. So you'll notice up here it says syllabus update to go along with that. So the syllabus update is, we used to have 17 weeks worth of content. We only have 15 weeks worth of content now. And I had already promised to drop your 2 lowest grades for lab and discussion. So these went down. Where it used to show 15 here, it only shows 13 because I'm still dropping 2 of the now reduced to 15 overall labs and overall discussions. So it shouldn't really affect it's a little bit less work, so you can focus on the midterm and the final, but it did make me have to adjust those numbers. The midterms are open book, so that's a good question. The midterms, there's no timer on them other than the fact that the midterm and the final are only accessible for that 1 week. So you have as much time as you want during that 1 week. And then once the week ends and you submit, then it's done. So you only get one shot at the midterm and the final. You have the whole week to complete it with no timer on it, and it's open book. So whatever resources you want to have handy, you can use those. Good question, Justin. Thank you for that. Okay, so that's changes. They're both in the future, but just so you know, I thought it was just putting too much on everybody's plate to have you do a full week's worth of content plus the midterm and the final. So in terms of the content coverage, I have taken the week 9 content and I'm going to mix it in to a few weeks. And then there was 1 week where I was going to try to get some bonus content squeezed in there during the final week, which we won't do. At some point, I'll talk about what that content was going to be, but it's not one of the central components of the course. So you shouldn't lose out on any content. That's the critical stuff. Okay, that's the change to the syllabus. If we look at the module view, I'll just show you what that looks like. If we go, so we have all the weeks that look normal, but if you go down to week 9, the only thing in there now is the midterm. That's the only thing for that week. It is published, but it doesn't open up until October 19th. And then week 17, I haven't published it yet because I don't have all the questions ready to build a final exam with, but the only thing on the week of the final exam will be the final exam itself. Okay, so those are all changes, and with that, I'm going to go ahead and get into, we're in week 4, which feels good. I don't know if you're having the same experience. If your life was disrupted by the fires and or power outages, then it either feels like life is racing by really fast, or perhaps it's going slower, hopelessly slow. For me, this semester right now is going fairly fast. So I've been trying to create content so much that I haven't taken a day off since July at this point. But the upside for me is that time is just flying. So I'm surprised we're already 4 weeks into the semester now. So let's look at this week. Let's look at this week, computer. There we go. Okay, so you're going to hear me talk about this when we get down into it, but the way I usually lecture this is, and what we're going to talk about today is, there are 2 kinds of path. And this is actually true in any computer system. When we say the word path, though, I like to be careful and say I'm talking about the big P path or the little p path, because they mean something slightly different on a computing system. So I will be careful and talk to you about what I mean when I say big P path versus little p path, but there is a difference. And then when we get down to little p path, we'll talk about the 2 branches of little p path, which are absolute path and relative path. I should be counting how many times I say path because I've already said it a lot. And then we finally get to the VI text editor. So you're going to hate it. At first, I think of it, it's a challenge because it's so different from any kind of text editing that you've ever done. It feels really, really weird, and you feel like you get stuck all the time at first, and you don't know how to get out of making a mistake when you're editing text. That's all true, but it doesn't last very long. So just be patient with VI. I think you'll find that just after a couple of sessions of trying to type some things in, that you'll get enough of the basics that you can actually edit text with the VI text editor. I'll come back to this when we get to actually playing with VI, but if you at some point ask yourself, why are we doing this miserable VI thing? The reason is because it continues to be sort of the universal command line text editor. So if you sit down on any Linux system or any Unix system, you're pretty much guaranteed that you're going to find the VI text editor in there, and possibly even sort of modernized versions of it. So if you know how to operate with VI, a person can throw you into any command line environment, and you're going to be able to do productive work because you can open files, you can edit text, you can create new files. You can do all of the things that you would need to do to be productive in a computing system. So that's why we like to have it. Another way to think of VI is it's kind of like driving a car with a manual transmission. If you learn how to drive a car with a manual transmission, there's really not any car that you can't operate after that. And that's a very empowering feeling. It also makes you a powerful computer user. But be patient because there's a good chance you're not going to like it at first. And if you decide that you never like it, you still at least know the basics of how to work with it if ever you find yourself in a situation where you have to. I'm a VI user, so I sort of went through the grind of getting past hating it, and now it's just sort of years of using it. I like it, but I realize it's not for everybody. Okay, so that's the goals for the week. Big P path, little P path, and then getting our start on editing text with VI. I'm just going to cycle through the module pages. So I'm starting to sort of dive down into the text and just have you focus on specific sections of the text. And please, if anyone finds a broken link at some point, if you could give me a heads up about that in Canvas Inbox or on Piazza, I'd appreciate it. And then there's a reading that I got from Geeks for Geeks because I didn't think that our text did a good job, at least not an adequate enough job of explaining the concepts of absolute and relative path. Okay, the lab is as normal, and I don't go through those, but I do want to remind you that I've been connecting to the labs a page of hands-on experiments. Does this open in a new page? I'm going to right-click it. So these hands-on experiments are, as I'm creating the lab assignment, it's what I'm actually doing on the command line. So as I'm practicing myself on the command line and writing your lab assignment questions, I'm also keeping sort of a record of what I've done so that I can share that with you later so you can do the same kinds of things. I also thought it can be difficult if you want to practice your VI editing skills to know what to type. So I tried to give you some things to type in the hands-on experiments. So most weeks from here on out, if not every week from here on out, there will be hands-on experiments linked into the lab where I walk you through what I've been doing to practice. So here's a little VI experiment, some reminders about the kinds of things that you might want to make sure that you're getting comfortable with in VI. And then finally, a little bonus exercise just to have a little bit of fun with something that's referenced in your reading. And then a note about using the change directories command to really develop a good feel for working with little P paths. So this one's a fairly small set of hands-on experiments. Some weeks you've probably already seen it. There's a whole bunch of screen captures. This one is really just showing you the file that I created so that I could practice my typing. I made a little to-do list. Okay, so that's the hands-on experiments that's linked to the lab each week. Hopefully you'll at least look at those before you sit down to actually answer the questions so you can see kind of what I had in mind when I was writing the assignment. Some of you have already started this. Your class, by the way, you guys are just really great at the Piazza discussion stuff. So you're just killing it. So thank you for that. If you haven't been there in a few days, by the way, one of your classmates had an error I hadn't seen in VirtualBox, and they managed to work it out for themselves. But we kind of had an ongoing discussion about that, and I was trying to figure out how to help, but I hadn't seen the problem before. Anyway, they figured it out. So there was a good discussion about that, and all your posts have been good. Some of you have already posted some notes about finding tutorials for using VI online. Vim, by the way, is an improved VI. You can hardly tell that it's improved unless you're comfortable with VI, but Vim is a slightly modernized version of the original VI editor. And then let's see what the reminders are. So this week, just to make sure you touch the two things if you want the points for them, the lab and the discussion. Okay. See a few new names in here. So welcome, Wardock, Axel Kitty. Who else haven't I said hello to? Bloodlust. Hi to people I didn't say hi to earlier. Thanks for being here. New setup. I'm using my elbow camera, but it has the mic seems to be working better than on my old laptop. All right, let me adjust my view and let's get into CentOS. And I'm also going to have my little morning. I'm also going to have my little notes on the side. So as I talk about a thing, I'll put some notes there on the screen to the side. Let me hide Firefox. Okay. So one of the reasons why we're doing CentOS like this, we're going to add graphics to it later. And one of your Piazza discussions will ask you to go and sort of explore what are the graphical options. Like what might we install to get a graphical user interface in our CentOS? So that's coming up, well, for you, probably in week 10 or so. For me, that's about the week that I'm on and creating content. But we are eventually going to add a graphical user interface onto our CentOS. But I want you to have the experience of working in a computing system where you don't even have the option of having graphics. If you can get comfortable doing that, then same kind of thing as the VI editor. There won't be a computer system that you won't be able to sit down and feel comfortable doing work on. Okay, so let me log in. Actually, let me put a note and start with a comment. So big P, path. Just put myself a couple of separators in here. So big P path, aka $ path. So fundamentally, it's a shell variable. And then we're going to look at that and see what the shell, that it is a shell variable, and then make sense of what the shell variable is meant for, what it means. So let me get to my CentOS. I'm trying to keep the chat window. So my user's name here is user, and my password is PASSWORD. Okay, so here we are. So if you want to see a shell variable, some of you may remember this. If I want to see the value of a shell variable, what's the command to actually see what the actual value of a shell variable is? Does anyone remember? You may not. Okay, that's okay, but this is a good one to remember. So if you want to see the value of a shell variable, use the echo command. Close. Cat is a way to display the contents of a file, so it's not unrelated. So it's a good guess, and cat is a useful command. We use cat typically when we just want to quickly sort of spit out the contents of a file. So in the bash shell, it's echo, and then you tell it the shell variable that you would like to view the value of. So we're going to echo path, and it's going to spit out some stuff. So here's what it spits out. So we know it's a shell variable because when I echo it, it spits out some output. So that tells us that there's information being stored in it. So let's see what it has in it. The colons here are the separators. So the first entry is home user dot local bin. We'll talk about dot today. And then the colon means going on to a different entry. So /home /user /bin colon means that's the end. So that's 2 entries. The third entry is /user /local /bin colon. Fourth entry /user /bin colon. Fifth entry /user /local /sbin colon, and then sixth entry /user /sbin. So that's the value of path. Its meaning is that the shell uses this information as a command locator. And we're going to use VI to come back to, actually, we might just, no, we'll come back later to this idea and use VI to explore it a little bit more. So the shell uses big P path, the shell variable, as a command locator. And what we mean by that is if I type a command, the shell has to go look for it. And the question then should be, well, how does the shell know where to look for it? Got my mouse caught. This is true in Windows, by the way, and it's also true on a Mac. This is basically true on all computer systems. How does the shell know where to go looking for a command when a command is typed? It's not magic. It uses a particular piece of information to locate that command. Okay, so I went ahead and typed it. When you type a command, the shell actually goes through the entries in your big P path to find it. That's how it works. So big P path is the locations in your file system that the shell will go look for a command. And it's kind of a first match wins. So the shell will go through these entries in your path until it finds a match. Once it finds a match, it stops and it executes the command. So big P path is really just a convenience. The way you can see this, by the way, if you want to see where the shell is actually finding, like ls, where's the shell finding that command? It's which, and then the command. Now it's an alias, but it also shows you here where on your big P path ls is being found. So when you type ls, it's aliased, but ultimately the shell finds that command in /user /bin /ls. So we'll go up here and look at our path variable and see if it's there. /user /bin, it's right here. So the shell actually had to take ls and look in this series of directories until it found a match. Once it did, it can execute it. So it finds it in /user /bin /ls. That's where the ls command is found on my path. So which ls, the output of the which command with ls is where the shell found, in this case, ls. So that's what the which command is for. You can figure out where the shell found something. Which one did it find? Come on. There we go. Okay, so that's what big P path is. It is an entry, it's a list of directories where the shell knows to go looking for commands. Now, if I were to type something like void, you'll notice that the output is command not found. So with big P path in our minds, the correct way to explain my problem right now in Linux and any other system, by the way, Windows also has a path. The correct way to explain what's going on here is that the shell looked through my path and could find no commands in my path named void. That can mean one of two things in Linux. If a command is not found, that either means one, it's not on your big P path. The shell looked through the list of directories and didn't find it there, but it could be somewhere else. Or two, the command is not installed in your system. But as an IT person, if you have a user telling you that they get a command not found error, your first question probably should be, is it installed but not on your big P path? Your second question would be, oh, it's not even installed. And if it is installed, it still needs to be on their path for them to use it. So that's big P path. I'm going to show you, can I show you this? Yeah, let me bring up, yeah, you're going to have to look at the mess that's my, no, I don't want to do that. Path is on Windows, and I'm trying to figure out how to show you that without making a big mess of the broadcast. Windows has the same thing. I'll just go in and I will, let me bring up the control panel, and then I'm going to show you the control panel in Windows. So Windows has this exact same concept. Where is it? There it is. Okay, so let me show you what this looks like in Windows. Where did it go? How do I get it? Oh, it's here. No, that's not it. Okay, have it back. Anyway, hopefully you're going to see what I see. No, you're seeing a different one. I lost the dumb thing. Here it is. Okay, so let me just show you what this looks like in Windows so that you're aware of this. So in Windows, they also have, they call them environment variables in Windows. These are shell variables. You'll notice, by the way, that they're uppercased. So although in Windows it's not case sensitive. So actually, as my user in Windows, I have a path entry here. And in Windows, the list is actually looks like a list. But it's the same concept. If I install a piece of software in Windows and I want it to execute, it has to be on my path. So even if you're doing Windows systems maintenance, you probably already know this. Sometimes you actually have to set, you have to alter path for a user in Windows for it to work. And then the system also has path, which I'm not a user that can do that right now. Okay, so anyway, just so you know, that same concept applies in Windows. Let me get it off there. Okay, so back to Linux. That is big P path. So you just sort of have to spend a little bit of time thinking about it. But this which command here is how you can figure out where the shell actually found the command. Now, we're going to do an experiment with big P path sort of at the end of the lecture once we get into VI, because then we'll be typing stuff and we can create something. And then see how the shell responds to it. I'm doing that just because I think it looks nicer. Okay, so that's big P path. Let's talk about little P path. So little P path, and the book may say this different. Big P path is a shell variable, and it's a list of directories that the shell uses to locate commands. That's all it is. Little P path is simply a way to describe the address of a file or directory in the file system. Which also kind of shows you this as well. So if I do a which CD as an example, this shows me where the shell found that command using my big P path, but the output is actually a little p path. This is the address or location in the file system of the CD command. And notice that it starts at slash, the root directory of the file system. So what we're seeing from that output right there is an absolute path. An absolute little p path is an address that's provided starting at the slash, starting at the root folder. So if I do pwd, that is an absolute path. That is the address of my present working directory from the root folder, from slash. Hopefully that makes some kind of sense. Okay, so that's absolute path. You can, and you're going to see it all the time. But one thing to remember about absolute path is that it always gives you the correct address. So you can never go wrong with absolute path. By the way, you can execute commands if you know their absolute path. You don't have to even have the big P path, the shell search for it for you. You can just type the absolute path and press enter, and you get the command to execute without having the shell have to go look it up for you. So you can always use absolute path to get at a resource on your system because it's always the correct address. Okay, so relative path is a little bit harder. Relative path is the address of a file or directory relative to your present working directory. So I'm going to do a harder one here as a means of explaining this. So let me clear this. Yeah, let me clear it. So I'm going to do a which on CD, let's say. Well, let's do cat, actually. Okay, so there's the cat command, which Linkridge brought out. So let's use that. So the which command tells me where the shell finds it in my path, and the output is the absolute path to the cat command. Now it turns out that I can actually get to the path to the cat command without using the shell big P path variable and without using the absolute path if I can navigate there relative to my present working directory. Now this one's harder, but if my present working directory is /home/user, to get to user bin cat from here, I actually have to go up 1 to home, up a second to slash, and then down from there through the user folder, through the bin folder, and to the cat command. Now, the cat's job is to take a file. I'll just put like a, I think I have a, do I have a file in here? File 2. Cat's job is to take a file and spit it out on the screen. Hopefully I was in a good mood when I typed that file, because otherwise it could have curse words in it. I'm just joking. It's empty. Anyway, so what I want you to see there, though, is that command, which I'm going to arrow back up to recall, I used a relative path there. So I went relative to my present working directory. I went up from my user folder, up through the home folder to the root, and then back down to the cat command. That is a relative path. That's kind of a wasteful relative path because I could have just used the absolute path without nearly as much typing. And I could have used the shell's big P path variable to let the shell locate it for me automatically and save myself even more typing. Okay, so I'm going to do a little bit more relative path. So absolute path is the address of a file or directory starting at root /. Relative path is the address of a file or directory starting at my current location. So let me, pardon me. Let me list the contents of my folder. So if I use -F, it'll put slashes on the end of the folder. So I'm going to go into week 5. So now I'm at week 5, and I just want to show you a couple of applications of relative path. So ls, by default, lists the contents of your present working directory, but you can, if you want to, say, you know what, instead list the contents of the directory one up from here. So in that command, ls space ... I actually used a relative path to tell ls command what I wanted a listing of, which is one up. So if you notice, one up is the contents that we were looking at when I was in my home, because my home is one up from my present working directory, which is week 5. Now that's a lot of stuff to take in. But the ... thing is a very important part of relative path. I'm going to go back to my home directory, and I'm going to do that using a relative path. So I'm going to change directories and go one up. I usually, by the way, when I'm addressing a directory, I put a slash on the command. You don't always have to, but I do it in part when I'm teaching, so you know I'm going up one directory. So now I'm in my home. So I can now, if I want to, I'll do an ls, which by default lists the contents of your present working directory. If I do an ls and say week 5, that's a relative path because it implies that I want a week 5 directory that's a subdirectory of the current one. And it has a bunch of week 5 files in it. So that's a relative path also. Now I can, if I'm clever, I can use the absolute path and do a listing using an absolute path to address that folder, starting at /, and I get the same results. So a sort of quick rule of thumb is that relative paths are often just faster to type than absolute paths. Absolute paths, however, are always correct, and relative paths, you can make mistakes because it can be confusing, like up 3 and down 4, that could be confusing. But it can be faster. Okay, so ... Let me give you the other sort of sneaky bits. We already knew this one, by the way. I'm going to have to scroll up eventually. Can you see that whole thing? You can. So ... that's... we haven't looked at dot because we don't often need dot, but I'm going to show you an example of where you need dot. Dot is a reference to the present working directory, and in most cases you don't actually need this, but if you know it's there, then it can help you in certain situations. So let me just let me get back into my CentOS and show you about dot. So I am in my home user. If I do an ls, by default, without any other arguments, it lists the current directory. But I can, if I want to, use the relative path shortcut to reference my present working directory. Now, how could that possibly be useful? Most of the time, it's not. So I can Say I want to list week 5, and ls is going to assume, oh, you must be in a week 5 folder that's a subdirectory of the present one. But you can be more explicit in your relative path by saying, well, start at the present directory and then go down into the week 5 directory from there. You can also do, oh wait, there's, let me, actually I don't know in this thing how to, can I can. Hold on, I'm dealing with some chat spam, sorry. What a pain. Who knows how long that's going to go on. Sorry about that. Okay. Irritating. Okay, so we're talking about relative path. Dot means the present working directory, and rarely do you type the dot because it's just extra typing when most commands assume by default that you mean the present working directory. But you can do weird things like, oh, I want a CD to the root. So here's my present working directory. So normally I would just go up to the root folder, but you can, if you want to, add // meaning start here, go up one, and then go up another directory, although that part is optional as well. So I want you to know that's there because I'm going to show you one example of where you need this today. But that dot and the dot, those are both important. Okay, we're going to add an ls just because I want you to see that actually the shell is aware of this dot and the dot as well. So if you do a -a, this is going to drop down, so I'll leave the relative path part showing. But I'm going to run this command ls-a. We're getting spammed by anybody else now. So the -a, you're going to see a whole bunch of new stuff pop up if you do -a. But the ones I want you to focus on are the dot and the dot. So if you do a listing and you ask for all contents of the folder, you actually get stuff that you weren't seeing before. The important ones for right now are the dot and the dot, which you notice if you're on your own machine, you'll see that those are blue. So the dot means the present working directory, and the dot means one up from here. These files that have dot in front of them, this is a little shell trick. So if you name a file with the dot as the first character, it becomes a hidden file, which a listing won't show without -a. So watch. All the dot files and the dot went away. With the -a, the dot and the dot come back, and all the what we call dot files, the files that start with their first letter being a dot, show up as well. This is a way that we hide configuration files and things like that. Or sometimes we just hide a file because it's rarely needed, but we want it there for some kind of information. Okay, so big P path, that's a shell variable. It has a list of directories in it that the shell uses to locate commands. Little p path is the address. That's a way of describing how do we address files and directories on the system. There's absolute little p path that always starts at root and it is always correct. And there's relative path, which is relative to your present working directory, and because it's always relative to your present working directory, it means that your relative paths to things have to change with your present working directory. The absolute path never changes. The relative path change as your present working directory changes. So anyway, the ways that you can experiment with this is with the change directories command, which you won't break anything that way, and the listing command, which also won't break anything. You can CD to move around using absolute path, relative path. You can do listings with and without the -A option, which will show you the dot and the dot dot if you're interested in such things. I can't remember if it's a question this week or not, but I'm going to go ahead and touch on it just to make sure. So I want to talk about the different ways while we're on path. The most important location typically for you on a Unix system or a Linux system is going to be your home directory, because that's the place that you own as a user, which means you can create new files and folders there without having to get special permission to do so in other parts of the system. So you're always sort of oriented to your home directory when you're working in a Linux system. And when you start experimenting, so I used a relative path there. I went up to and then down into the user folder, which took me into /user. When you start doing these experiments, you can get away from home, your home folder. And I just want to show you real quick, and I may have done this, but I'll repeat it. How do I get back home from somewhere in the system fast? Actually, I'll give you a couple of seconds. Some of you may know the different ways we can get back to our home folder super, super fast. Or not so super fast, if you know some not so super fast ways to do it. That's close. We can build on that. So home is close. You're going to need a change directories. So you're going to have to CD somewhere. So now CD home, actually Justin has got a good one to work with. That's a relative path since it doesn't start at root. And for that, okay, yeah, that's true. So if we do this, this is a relative path, and this assumes that the home directory is a subdirectory of the present working directory, which in this case it's not. So let's see if we can build on that. Here's my present working directory, and where I want to go is my home, which is /home/user. So what is a way I can get from here to home? That won't work. That just assumes that is a subdirectory of the present working directory, which it isn't. There is no directory called /user/home. So there is a /home. So let's keep building on that. But this is good, Justin, because we can build on this. Try with absolute path. Or you could use a relative path. So here's my present working directory. I'll show you what my home is. That's where I want to go. That would work. So this will work. I can CD. So this is a relative path. So Justin's onto something too. So I can actually combine it all into one. I can CD one up and then go down into home user. So that worked. Here's a tip, by the way. If you want to jump back to the last place you came from, you can do CD minus. Yep, that's right. So that's one way to do it. By the way, CD minus took me back to user. So this is one way to do it. Let's improve upon it. Is there a part of this we could get rid of? So this is a good relative path that works. Is there a part of this we could get rid of? Sort of look for I did a PWD way here at the top of the screen when I was in my home, which PWD shows you an absolute path. So in this case, you can just do the absolute path. There you go. So that's good, War Dog. We can just use, that's right. You can get rid of the two dots and just use the absolute path. If you know the absolute path, you can just use it that way. So those are good. Those are all good ones. Now, because home is so important, so I'm going to use CD minus to go back into /user just to make ourselves do the work. Because your home is so important, the shell actually has shortcuts. So the quickest shortcut to get home is simply CD with no arguments. So that's there as a convenience in the shell. Because your home directory is so important, you don't even have to supply a relative or an absolute path. It will just automatically take you home. And I'm going to use CD minus to jump back to the last place where I was, which is the user folder. So CD with no arguments jumps you straight home, which is good to know. There's also a couple of other shortcuts you can use. They're not as good as just CD with no arguments, but if you use the tilde, the squiggle, that also takes you home. Hold on, I've got a mess on my desktop all of a sudden. And then I'm going to CD minus to jump back to my last location, which is /user. I'm going to clear in PWD. So here's where I am. So we looked at CD, press enter, you're home. CD tilde, squiggle, press enter, you're home. There's a shell variable called home, which is a third way you can do it that takes you straight home. I gotta organize that better because I keep having to jump around. So this will take you home. And then as you guys pointed out, we can use a relative path to go home. Or we can use an absolute path to go home. So there's 1, 2, 3, 4, 5 different ways you can go home. CD, CD tilde, CD $ home, CD relative path, CD absolute path is 5 different ways you can get from anywhere on the file system into your home directory. All right, so that's kind of interesting. Okay, so we've got a few minutes left. I'm going to do a little bit of VI stuff. But here's just sort of a tip. If at any point you forget where you're at in the file system and you just want to go home, just type CD and hit enter and you know you're home. You can always use PWD to confirm that, but you know you're home. Okay, so we're going to do a little bit of VI, and I'm going to try to go slow on this, but I also just want to get you some of the critical things. So I'm actually going to make a folder. I'm in my home. I'm going to make a new folder here called week 4. Whenever I'm, by the way, that's a relative path. That's a relative path. A week 4 folder off the present working folder. I could also have specified an absolute path to where I want to make that folder at. But most of us would just type it this way because the commands are going to assume that unless otherwise specified, you mean the present working directory. So this is going to create a new folder, week 4, in the present working directory. And I just think it's good habit to be in. When you're writing commands and you're addressing or targeting folders, put a slash on the end of them. There's a particular kind of problem that I'll talk about at some point that you can just avoid by doing this. All right, so now if I do an ls, I've got my new folder. I can do -f and it'll put slashes on there. So I'm going to change directories. I'm going to use a relative path with dot. But remember that the dot is implied. At least in this case it is. So that's a relative path where the present working directory is implied, or I can be explicit about it and say the week 4 directory off the present working directory. That's a relative path. All right, so now I'll do a pwd. It shows me the absolute path of where I'm working, and I did this because I want to sort of contain what I'm about to do in here. So now some VI stuff. And I'm going to try to just give you, you don't need that much to actually be productive in VI. You need to know how to get to the point where you can type text in and how to get away from that when you don't want to do that anymore. And then, like, how do I get out of VI and how do I escape when I've made a mistake? So let's see if we can get those things working. So in VI, you open a file for editing by giving it a file name. Now I'm going to do a listing here and just show you there's no files here right now. So I'm just going to call this today. In Unix, by the way, files don't need to have extensions. Unix doesn't actually use the extension to know what a file is in most cases. It actually looks inside the file for that. Anyway, so I'm going to VI a file called today. I guess I can call it .txt. No, I'm not going to do that. I'm just going to call it today. So if the file does not exist, VI will create it. If the file does exist, it will open for editing. So here we go. Press enter. I'm in VI. If you're not seeing all the stuff that I'm seeing, it may be because I've worked ahead of you a little bit. Oh, yeah. Okay, sorry, I was showing line numbers, and you know what? That's fine. You're not going to see all the same. In fact, pretend like you don't see what it is that I'm about to do. All right, here we go, today. Sorry, I was working ahead of you by several weeks, and I had some stuff put in here. Okay, got VI running. It created a new file. Hopefully you're seeing something similar on your screen if you're doing this along with me. It's created a new file because the file didn't already exist. If the file exists, it will open it for editing. Now, one thing you're going to notice, just kind of pay attention to the keys you're pressing. The movement keys are H, J, K, and L, but in most cases you can also use the arrows. Anyway, H, J, K, and L, which I'm pressing right now, H, J, K, L, H, J, K, L, nothing's happening. And the reason why nothing's happening is because this file has no contents. So a line in VI that has a squiggle, a tilde on the front, that's an empty line. There's no contents. So VI really just kind of fills the screen and waits for you to add stuff to it. So let's do the most basic of things. I'm going to press the I key, and I'm going to press it once, I. So if you press I, you are now in insert mode. And you can see that being printed at the bottom of the screen, insert. This is the most basic typing mode of VI. So if you are in insert mode, you are ready to type. And if you press enter at the end of a line, you'll get on a new line. You'll notice that the tilde went away on the new line. I can press and make a blank line. I can space over a little bit. And notice that all the while I'm in insert mode down here. So this is the tricky part of VI. So I'm going to enter one more, and VI is modal. And what we mean by that is that VI operates in two modes, and you need to be aware of what mode you're in before you start pressing keys. So right now I'm in insert mode. And insert mode means that I'm typing text. I'm inserting text. If you want to go into the other mode, which is the command mode is how you save a file, how you quit from the program. You need to be in command mode to do fancy editing commands like copy and paste and deleting. You can backspace over stuff. But generally, command mode is when you want to do something that's not simply doing basic typing. So to get from insert mode back into command mode, you press the escape key. And you'll notice when I do that, the little insert prompt goes away. So these are by far, while you're inside of VI, the most important things to know. You press I once to get into insert mode and then start typing. And then when you're done with insert mode, you press escape. And then one kind of just bail yourself out recommendation. If you forget what mode you're in, just hit escape a whole bunch of times. So I'm just bashing away on escape right now. So if in doubt, just press escape a whole bunch of times, and you know that you're in command mode. And then from here, you can do other things. So you can, for example, press I once, go into insert mode again, and start typing more text. Escape to get out. So insert to begin inserting text. When you press insert the first time, it's not going to print an I. It's going to put you into insert mode, and then everything from there on counts. So those are by far the most important things to remember, and most things you can figure out how to do with those and, let's say, 2 other commands. So if I'm ready to save and quit a document, I need to be in command mode. If you're in doubt, bash on escape. I'm in command mode, so to save, or in VI terms, write and quit, is :WQ. So I'm in command mode, escape, escape, escape a bunch of times. I'm in command mode, I'm positive of that. So I'm going to press a colon. And if you're watching, you'll see that there's a colon now blinking at the bottom. And this is waiting for some kind of command. So I want to write the file, save, and quit the program, Q. So when I do that, it'll tell me today was written, and then I'm back at my command prompt. I'm going to clear. There's my today file. So I'm going to open it again. VI today, this time the file already exists, so it will not create it, it will just open it. This is where you have a chance to practice, so if in doubt, escape. Be in command mode, in command mode. Now you can start practicing with the keys, with the arrow movement. So H moves you to the left. I actually have muscle memory for this, and I have to actually sort of do it and then watch what's happening. H moves you to the left. L moves you to the right. K moves you up. So you see my cursor going up, and J moves you down. It's also true that the arrow keys will do that. So if you forget H, J, K, and L, you can use the arrow keys to move around. The reason why the cursor is jumping like that is because that empty line is literally empty. There's nothing on it. So okay, so that's cursor movement. Now let's say I'm going to go into insert mode. At first, until we add some commands, you're going to find some things that are a little irritating, like it put that extra dot, so fine, I'll just back over the extra one. I'm in insert mode, you'll notice, so I'm just typing some stuff. So let's just say I decide I don't want this line on here. I made a mistake. What do I do? Well, the first thing to not do is to try to save it. But I guess sort of the before that, get into command mode. So I'm in insert mode now. So I'm just going to bash on escape a bunch of times. I'm in command mode. Yes. So Justin asked, will :W write or save without quitting? And yes. So if you just do a :W, it'll save the file and leave you in VI. It won't quit. So good question. And that will allow you to save and then continue your editing work. Good question. The Q, by the way, and I'm going to show you this actually, the Q will quit without saving, but that can be a problem if you did an edit. So let's look at this example. I did an edit. I'm in command mode, bash, 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 bash on escape. So, oh no, I don't want to do that. I'm going to quit. Don't save, right? Well, the problem is that VI is now unhappy with me because, but wait, you made changes. Don't you want to save the changes? Now, it is telling me I can override this, and this is a very important command to know. So just make sure you're in command mode, escape, bash, escape. So if you need to get out of here and you don't want to save the last step that you did because you made a mess of it, you do a :Q bang, exclamation point, which will get you out of here without saving any of the mess that you just made. Let's actually clearer. I spelled it funny. So now if I go back into today, you'll notice that mistake line is not there because I quit without saving. So QBang is important to get yourself out. Now, if you haven't made any changes and you try to quit, VI is cool with that. But if you have made changes, then VI is gonna want you to override the quit command because it's gonna want you to be sure that you saved if you meant to. With those things, you can actually start to do productive work in VI. The trick here is you're not going to like it at first. It just feels weird, and you accidentally type stuff when you meant to be in command mode, and you're typing commands into the file because you forgot that you were in insert mode. So that is going to be frustrating at first, and there are a lot of other commands, but I don't want to overwhelm you with those kinds of things. Am I out of time? Darn, I've run out of time, so let's do it. Bonus content, kind of, but it's a path thing. This one's hard. So this is not something that I'm challenging you about on the lab, but I want to show you this. It's a difficult thing, but it's related to path. Big P path and little p path, so I want you to see it, but it takes some do I want to do that? Yeah, let's do it. I already said I'd do it, so let's do it. So I'm going to make a new file in my week 4 folder here, and I'm going to just call it greet. So a new file, because that file wasn't there before. I'm going to press I to get into insert mode. And you can see the prompt at the bottom tells you you're okay, ready to insert. I'm going to type a command in here, actually, an echo command. followed by a message that says hello from a file with quotes around it. Now I'm still in insert mode. So I'm going to hit escape to get out of insert mode. And if in doubt, just bash escape a bunch of times. So now I'm back in command mode. It doesn't say command mode, so you have to get used to that, but it will say when you're in insert mode. So I'm in command mode, so now I can do a colon, write and quit, WQ, which will save it as a file. Now this is a command inside of a file. So what we're going to do is just a little path experiment real quick in the last couple of seconds. So I'm going to have echo quote hello from a file, close quote, then I pressed escape, and now I am colon WQ to write and quit the file. Hopefully the pace of that was enough that you could peck it out and follow the experiment if you're interested. So clear ls. Okay, so I want to show you a trick here, because what we're going to do is we're going to use a command that you're going to see a whole bunch later in the semester. This is called the change mode command, but you can use it. +X means make executable. You can use it to make one of your files that you created be executable, a script. So this is a little sloppy, but we're just doing a quick experiment. So that is chmod, change mode is how most people would say it. +X, that means to make this thing executable, and then the greet file. So I want to actually cause the command inside of my greet file to execute, that echo command. I want the file to actually run that command. So I am making the file executable so that it will do that. Now if I do an ls, the reason why greet is green now is because the shell recognizes that this has executable stuff inside of it. In our case, it's an echo command. So we've just created a script that should print out hello from a file if we run it. So this is why we did all of this. Because what we want to do is just run that command. But it's going to say command not found. So I'm just going to talk you through the detective story here to remind you how big P path and little p path works. So I typed greet, and the shell says command not found. So we need to sort of remind ourselves of why that is the case. I'll show you my present working directory, and then I will show you my path. So when I typed greet and I got command not found, what the shell does when it's given a command is it looks through the folders in your path to see if it can find that command. And it's going to look through all of these folders and find greet in none of them because it's in my week 4 folder. So my week 4 folder containing my new greet script is not in my big P path. So the shell can't find it. The solution to this problem is instead to tell the shell where it can be found. There's 2 ways to do that. One way to do it is to give the shell the absolute path to my file with a command in it, and it will execute it. Since greet is executable, if I just provide its absolute path on the command line and it's executable, the shell will go there and execute its contents. So there's hello from a file. There's a faster way to do this though, and this is the one case where the dot comes in handy, because remember when I typed greet, I get nothing because the shell looks through big P path. So I have to tell the shell to use a little p path to find this thing. I did that way and gave it absolute little p path, but I can also more quickly say, actually, it's a command right here in the present working directory. understanding this dot and this slash is a huge deal, at least in my teaching work. I have to teach this to my programming students every semester because they don't know path, big P or little p path. And so why the dot slash is a mystery. But anyway, the reason why the dot slash is because if the command is not on my path, big P path, but I can provide an absolute little p path or a relative little p path, then the shell can find it and execute it. Pretty neat. At least I think it's neat. Okay. That whole greet thing was kind of bonus content, but it's coming back later. So if you sat through it this time, then the next time we talk about it, maybe you'll remember a bit. Thank you for being here. I hope everyone, if you were having your life be disrupted, that's settled or settling out for you. Have a good rest of your week. I'm going to stay here for just a minute or two, and I'll see if any questions come up. Otherwise, drop a question in Piazza, drop me a Canvas box message if you have any questions, and we'll just keep doing what I think is the good work that you're all doing. Thanks, Lickridge. Thank you, Justin. Appreciate it. Appreciate you guys throwing down a little bit on the chat. It helps me a lot to know that you guys are out there. So have a good rest of your week. Just get in touch if anyone needs anything or have questions. Otherwise, I will see you on Tuesday next week.